So finally, I've come out with a solution to the queen's attack problem in HackerRank, and we are going to be solving it right now. So if you look at my screen, you see I've actually been doing a whole lot of things trying to understand this problem. So you can see a whole lot of things I've been doing right here, just trying to understand this problem. Actually, I promise you don't have to do all of this because I figured out a breakdown, an easy way to solve it. And now I've also been writing this program in PyCharm just to find a way to clarify it. Now, I've also written the explanation here in my website, Queen Attack Problem Solution in HackerRank as well. So you can see that I've actually spent so much time working on this problem, and at this point I'm going to break it down to you. It's going to be a very clear solution that you are going to see right now. So let's dive right in. First, if you go to my website, so let me just show you how to get to my website. If you go to Google and type Kindson the genius, it takes you to my website. So if you go to the home page, you simply scroll down, or you can just, you scroll down, you find it right here. So there is a page. Now it says this is simple and clear solution to the queen attack problem. It takes 3 steps. Make no mistake about it. It takes 3 steps. 1. Determine all the cells the queen can attack without obstacles. It's called queen cells. 2. Determine all the cells blocked by the obstacles. 3. Return queen cells minus pawn cells. Now let's go back to the problem and let's understand it. It says you'll be given a square chessboard with 1 queen and a number of obstacles placed on it. Determine how many squares the queen can attack. A queen is standing on an n-by-n chessboard. The chessboard rows are numbered 1 to n, going from bottom to top, and the columns are numbered 1 to n, going from left to right. Each square is referred by a tuple RC describing the row and the column C where the square is located. Well, instead of continuing to read, let's just explain it in my whiteboard. So I'm going to a new page, and now we have this board right here. Let me increase it. So now we have this board, and we are given a queen placed on the board, which is this queen sitting right here. Now this queen can attack diagonally, and there are 2 diagonals cutting across the queen, and it can also attack orthogonally, which is horizontal and vertical, right? So if we want to calculate all the cells the queen can attack, which is the first function we are going to work on. So the first function, cells queen can attack, we are going to calculate first. It's going to be if wherever he sits, he can attack horizontal, vertical, which means 2n, but we are going to subtract 2 because we are not going to count where the queen is sitting, okay? So this, we call this orthogonal, which is horizontal and vertical, right? So the next one, we are going to calculate for the diagonals. Now this is where it gets interesting, because to calculate the total number of diagonal cells the queen can attack, we need to use a formula. So let me just go to my website, and I'm going to show you this formula right here. So this is a formula right here where x and y are the coordinates of the position of the queen. So if the queen is sitting at position 4-3, and the queen is sitting at position 4-3, we are going to have this formula to be used to calculate the length of the diagonals. Now I'm going to apply this formula, and let's just make sure it works. Now you don't have to worry about how to derive this formula. You simply just know that this formula works. So this formula says, let's see, it says for the diagonals, I'm going to write for the diagonals, is going to be this formula, 2n minus 2 minus absolutes x minus y minus absolute value of x minus y, x plus y minus n minus 1 absolute value. So if you're in an interview, simply use a cheat sheet or maybe have a reference to this formula, because you have to use this formula. That's the easiest way you can get to the solution. And it doesn't matter, you don't need to know how to derive this formula. Alright, so the number of diagonal cells when queen is sitting at position 4, 4. Now, another thing I want to tell you is that the coordinates in this problem is giving us y, x. So it is not what we normally do like x, y, okay? This is x and y, and we normally say x, y. Let's say we have 2, 3. It means 2 on the x-axis, 1, 2, and 3 on the y-axis. In this case, it's the other way around. In this case, we are given it is the same as 3, 2. So that's one thing you need to know about this problem. The coordinate is given as yx. Okay, keep that in mind. So if we want to calculate how many cells this queen can attack, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 for a queen sitting at position 4, 4. So let's fix in these values and see how it goes. So we have x is equal to 4, y is equal to 4, and n is equal to 8. And we calculated how many of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 of them. So we calculated 13. Let's see if this formula works. So if I'm going to fix this, the values here, I'm going to say 2 into 8 minus 2 minus modulus 4 minus 4 minus absolute value, not modulus, 4 plus 4 minus 8 minus 1. Alright, so it's going to give us 16 minus 2, of course, minus 0 minus absolute value. 4 plus 4 is 8 minus 8 minus 1. And that's going to give us 16 minus 2 is going to give us 12, 14 minus this value here, and it's going to say 8 minus 8 minus 1 is going to give us minus 1. So it's going to give us 14 minus absolute value of minus 1. It's going to give us 1. It's going to give us 13. So this formula checks out. So that means that the number of cells the queen can attack, if we use this one here, 2n minus 2 is going to be 16 minus 2. 16 minus 2, which is 2 times 8 minus 2, is going to be 14. So the total number of squares the queen can attack without obstacles will be given by 13 plus 14, which is 27. Okay, for the fun of it, let's write this part of the problem in case of when there are no obstacles, and let's see that we are going to get a good result. We are going to pass some test cases in case of when there are no pawns. So I'm going to come here and I'm going to write a function that says get cells queen can attack. So let's write a function that says get cells queen can attack. So in this case, for us to get the cells queen can attack without obstacles, that is what we are trying to get here. So if we apply our formula, I'm going to calculate for orthogonals. Orthogonals is equal to 2n minus 2. So it's going to be 2 times the board size minus 2, and diagonals is equal to, so if I'm going to fix in that formula, it's going to be 2 times board size times absolute times 2 times board size minus 2 minus absolute value. So I'm just writing this formula I told you just now. Queen x minus queen y. So queen x and queen y is the position of the queen for the x and y values. So queen x minus queen y minus absolute value and specify queen x plus queen y minus n minus 1, minus both sides minus 1. So this is simply the formula I told you, and we are simply going to return the sum of them. Return orthogonals plus diagonals. So at this point, if I come here and just say, I'm gonna just say, let me just call it queen cells. Let's call it queen cells. Queen cells is equal to get cells queen can attack, and I'm going to give it queen x. Now let me just tell you about something. You see these names here? I would like us to change it. First, I'm going to change this one to pawns, because in a chess game we have queen, we have pawns. Now this is the board size, so I'm going to just change it to board size. And this K is actually irrelevant, completely irrelevant. Now this is the row of the queen, and this is a column for the queen. So this is a row, and normally we say this is X, but in this case I told you it's inverted, so this should be Y, queen Y, and this will be queen X. The column is going to be X. So if I'm going to call this function and then give it these parameters, I'm going to give it queen x, and queen y, and the board size, and that is fine. So if at this point I say return queen cells, at this point this is going to give us the correct answer for situations where there are no obstacles. So let's run this code and let's see. So I'm going to run it at this point and let's see what happens here. So at least we are close. We can say we passed 2 test cases, as you can see right here. Test case 0 and test case 1. In this case, there are no obstacles and the test case passed. Now let's modify this function first. So let's come here and say that if the pawns, the number of pawns is 0. So if the length of the pawns, if the length of the pawns is 0, then we are going to return what we have here. So we are going to simply calculate this and return it. So I'm going to put a column here, and else then that's when we now have to do some work. So at this point we have to solve what is going to be here, because now this is okay. Now we're going to worry about the obstacles on the board. And that's why I'm going to go to my whiteboard to just show you what is going to happen here. Now what is going to happen here is that first, let me just tell you that if there is an obstacle in the board, let's say obstacle at some point, x and y. These obstacles can either be on top of the queen, below the queen, to the right of the queen, to the left of the queen. It can also be along one of the diagonals of the queen. So these are the only 8 places an obstacle can be for it to be important. So I call this, so let me scroll down a little bit. I call it U for up, D for down, L for left, R for right, and we have upper right, lower right, and we have upper right. I call it down so that I don't mix up left and lower. That's why I use right. I use down. So down right, then we have down left. So we have up right, down left, and so we have up right, down right, we have down left and up left. So basically, let me just show you what I'm doing here. So I'm going from here, 1, 2 is up right, down right, we'll have here down left, we'll have up left, right? So it makes sense. That's how I go. So the next function we are going to calculate, we are going to calculate, because if you go back to my website, we are going to calculate the relative location of a pawn. So given a pawn, we are going to check at what point is it? Is it up left, down left? So we are simply going to return one of these. A pawn can only be in one of these locations. So we are going to say given a pawn and a queen, at what relative location is this pawn? So how do we do this? I'm going to go to the chessboard at this point. So we are going to do it in this way. I think, okay, yeah. So if a pawn, maybe I'm going to just copy another, let me copy from my website. So I'm going to copy this one, let me copy this image from my website. And I'm going to just start a new page so that it becomes clear. So let me paste this. Okay, perfect. So what we are saying here is, if a pawn, which is this P, and a queen is, if a pawn and a queen is in the same column, so meaning that the X, the pawn X, so we are saying that we have, this is Y, this is X. So if they are in the same X, is equal to queen X. If they are in the same place, then this pawn can only return either U, which is for up, or down for D. And how do we know? Because they are in the same X position, and then we are going to check for their Y position. If the pawn's Y position is greater than the queen's Y position, it means that the pawn is somewhere here. But if the pawn's Y position is less than the queen's Y position, then the pawn is somewhere here. So in this case, we have the X, because I told you before that this is giving us YX, right? So we're going to check the X, and 1 second. Okay. So we are going to check the X. If the X is the same, you can see they are the same here. Then we are going to check the Y, and in this case, the pawn Y is lower, then we are going to return what? We are going to return D. Else, we are going to return U. I'll do the same thing for the pawn. Like in this case, we have the X. In this case, the Y, because I told you it's the other way around, is the same, but the X is different. Then we are going to return, which is L, else we return right. So I think this should be clear. So I'm going to go code out this function, this helper function that returns either U, L, D, R, and so on. Let me go to HackerRank, and then I'm going to code out this helper function, because it's really very important to have this helper function. So I'm going to say DEF, I'm going to call it get relative location, and given queen X, given queen Y, given pawn X, and given pawn Y. So I'm going to write out this code, and then I'm going to fast forward this video because I already explained it. Okay, so we've completed coding out the get relative location of a given pawn. All right, so let's see. The next thing is the next function we are going to write, and I think this is the most tasking function, which is get blocked cells by pawns. All right, let's go and explain this right now. So what we are saying here is, at this point, if you have calculated all the cells that the queen can attack, you need to now calculate all the cells that are blocked by the pawn, namely this one, this one, this one, this one, and it's going to give you how many of them? 1, 2, 3, 4, right? So it's going to give you 4, and then you subtract. But the question now is, how do you know which cells are blocked by the pawn? You need to use the relative location of the pawn. Now, if the pawn is located at the position L, let's take for instance, if the pawn is located, okay, let's start with, at position L, for instance. So what we are going to do, we are going to have the value of y remaining constant, and then you are going to iterate from x to 0 and get all the cells there. In this case, the value of the x remains constant, and you're going to iterate from this case to the value of y down to 0. In this case is where p, or the pawn, returns relative location of d, which is down. And the same thing goes for left and right. Now, in case of the diagonals, if the position of the pawn returns ul, is diagonal, then now we are going to iterate in both directions. So let's take, for instance, let's just take an example. In this case, we have this guy here, and actually we have no use for this guy. But if we're going to iterate, we're going to say 5 to 5, and that gives us 1. So assuming that we have a pawn here, and it's going to go down this way, and if this pawn is at position 3, 4, so we are going to iterate, we are going to continue to increase until any of them gets to n, right? We are going to increase until any of them gets to n, and that is the way we can count the number of cells in that direction, right? So for up and down, you are going to increase one of the values until it gets to n. For diagonals, for cells, for pawns placed in diagonals, you are going to start from the position of the pawn and be increasing or decreasing in case of the ones placed right here until the bot size, any of these values get to the bot size. So, and that makes sense because in this case, if we are checking what the queen attacks, we have 1, 2, 3, 4, 5, 6, 7, 8, right? We have 9, 10, 11, 12, 13, 14. So we have 14. And in this case, we have 1, 2, 3, 4 minus 4. That's going to give us 10. And that is the answer for that particular test case we see in HackerRank. I'm going to just go back to HackerRank to show you the very test case we just checked, which is this one. We can see the output here is 10 because our logic works perfectly well. So using this logic I told you, depending on whether it's up, down, or to the diagonals, you're going to increase one of the parameters until you reach the bot size. And for each of the increments, you're going to add to a set. You are going to add it to a set. So you're going to add x and y to the set. The reason we are adding x and y to the set is because, for instance, if you are counting the cells blocked by a pawn, if you have another pawn here, let's take, for instance, you have another pawn in this position, it's going to count, this pawn is going to give you 1, this cell, this cell, this cell, which is how many 3, and this pawn is going to give you this cell, plus 2, 5, which is wrong because the number of cells blocked here is only 3. So meaning that we need a data structure that is going to reject or that will not hold duplicates. So as we are going to be adding the locations in a set, we need a set that is going to be holding items that does not need to have a duplicate. So for this set, alright, so what we are saying is that to avoid the duplicate, we are going to have a set that holds the coordinate 1, 2, we have another one, 3, 2, and we want to insert another coordinate, let's say 3, 2, and this, it finds it in the set, it's going to reject it, or because this set is not going to need a duplicate. I'm going to go to HackerRank now, and I'm going to code out this function that's going to calculate the number of blocked cells, by the pawns, and then we continue from there. So I'm going back to HackerRank right now. So again, I'm going to kind of fast forward and then write the code and then I'll get back to you. Alright, so at the end of the day, we are going to simply return the blocked cells we've calculated, and it's going to be from here. So I'm going to simply return the number of items in the blocked cells is going to be length of the blocked cells. So I want to just check and make sure I'm not having bugs here. So we have for DL this 0, 0, minus, minus, for DR is equal to Y minus, Y goes to 0. I think everything should be fine here. Alright, so we now have the cells blocked by the pawns, and we also wrote, I don't know why this window keeps moving, so I'm going to kind of set it to full screen. So let me set it to full screen. Yeah. So at this point we have get relative location, we have get cells blocked by pawns, and we also have get cells queen can attack. Okay, so let's complete this program. So let's write the main program here. And this is where we are going to write it. This else part now, we are going to complete it. So I'm going to simply say queen cells, although we should have moved this queen cells outside this if statement. So let me just move it outside the if statement so that we just have one of this here. So yeah, it's going to be here. So I'm going to just return it if there are no pawns. Else, I'm going to calculate the pawn cells is equal to get cells blocked by pawns, and I'm going to give it queen X and queen Y here, and give it the pawns, okay? And at the end of the day, we are going to simply return the queen cells minus the pawn cells. Alright, at this point we are done with this program, so I'm going to run it now and let's see how much we've done. So let me run the code and let's see. Okay, yeah, so we have an error. So we have tuple cannot be interpreted as integer. Yeah, so we have to remove one of these braces here. Yeah, that should be it. Yeah, so run the code one more time. And at this time we have a wrong answer. We have 9 here. Now let me explain what the problem is because this kind of gave me some tough time when I was trying to figure it out. Now if I go back to my whiteboard, I told you that there are some cells, for instance this one, that is inconsequential. It is not lying in diagonal of the queen, so you can see diagonal of the queen is this, and this cell here is inconsequential. It never has nothing to do with the queen. Now, to clarify this, let me just go to my website and copy the other diagram I have there so that you understand what I'm saying. So this diagram here, let me just copy this image. So we are saying that when you have a pawn here that lies outside the diagonal of the queen, then we don't have to count it. But in our example, all of them were counted, and then we have more pawns as cells where what was calculated, and when you subtract it from the queen, it gave you something smaller. Yeah, so but the pawn cells actually should be lesser, so that when you subtract from the queen, you have a higher value. So how do we ensure that the cells we are counting is lying in the diagonal of the queen? Now, when we are counting the pawns, the ones that are up, down, or left and right does not matter, because if they are up, down, left, right, they are always in the path of the queen. But when the pawn is in a different place that is not up, down, left, right, when it's not in the same row, it's not in the same column, then the only condition that's going to make it be in the diagonal of the queen is when the queen x, when the distance from the x, let's just say from here, when it has the same distance, x and y distance from the queen, right? So when it has the same x and y distance from the queen, that is when we can be sure to count it is in the diagonal. When queen x, sorry, let me just write it out clearly so that we can get it right. So when queen x minus pawn x, queen x minus pawn x, this value here, the same distance, it has to be absolute distance because we are looking at the absolute distance. Absolute distance, it could be in either direction, has to be the same y distance. So it's going to be queen y minus pawn y, and this, when this condition is met, then that is the only time we can take that pawn into consideration. So let me go and include this in my code and let's see what we have. If I get back to my code here, so we are saying that when we are calculating get relative position, we're only interested in the ones that lie in the diagonals, and it's going to be from here. I'm going to say if the absolute value of queen x minus pawn queen x minus pawn x is the same as the absolute value of queen y minus pawn y, and this is the only time we are going to take it into consideration and return the relative location. Yeah, so this is the only time we will take it into consideration when we have this criteria right here met. Okay, so I'm going to run the code again and let's see what we have. So now it passes all the 3 test cases. I'm going to submit this code and let's see if it passes all the other test cases. So you can see that it failed some test cases. So let me go check where the problem is coming from. I think the problem is coming from here. So for DR, we have the pawn y has to be and x has to be greater, and this is going to be for DL. Okay, so let me resubmit this code and let's see, submit. And now you can see that it passes all the test cases and we have successfully solved this problem. So I'd like to thank you for viewing. Meanwhile, you have here in my website, you have the explanation, though the explanation might not be as detailed as I have explained it in this video. And you can find the source code here on my website. You can also check my GitHub repository. I'm going to place this code in GitHub so that you can have it as well. I'd also like to remind you to subscribe to my channel here so that you don't miss any update from me. If you have any challenges, please let me know as well. I remain Kindson the Tech Pro, and I'm always there for you.